Good morning, good afternoon, good evening. Welcome to my next podcast brought to you by PM Powered, your consulting company for project, program, and portfolio management. I'm Wanda Curley, your authority on project, program, and portfolio management. So let's get started. I'm coming to you from Florida. I'm visiting my mom, so I'm at her house. So you see the background is different. I was hoping to come here to really warm weather. I left 0 degrees in Philadelphia and got here and it was only in the 40s. So it was still kind of chilly, but for me it was a heat wave. So it's great to be here. So let's get going. I'm going to be talking about AI and nanotechnology, but before we get into that, I found an article by MIT. It was a technology review, and they analyzed 16,625 papers to figure out where AI is headed next. So they looked at it over 25 years of artificial intelligence research. So let's go into a little bit and how they defined AI and some of those things. So almost everything you hear about artificial intelligence today is thanks to deep learning. This category of algorithms works by using statistics to find patterns in data, and it has proved immensely powerful in mimicking human skills, such as our ability to see and hear. So if you think about AI, it is really doing that. It can see and it can hear what we're saying. Think about Google technology. Think about Siri. Think about Alexa or Cortana. Yeah, they're having some problems with the hearing, especially with women, because we've got that higher pitch, but they're doing pretty good. So we can see these capabilities also in Google search, Facebook's news feeds, and Netflix recommendation engine. I know when I get a recommendation from Netflix, it does pretty good, although there are things that I have no desires to see that it recommends that I see. Now, when I get more into this article, I'm not going to tell you everything about it because there's literally things that I don't understand. So let's get going a little bit. So where did MIT go to find all these articles? They used a scientific database called Archive. It's AR capital X IV, lowercase IV. So, and they downloaded abstracts. So that's the little teaser that you get before the paper. If you don't know about scientific journals, they always have scientific articles. They always have a little abstract beforehand. And they did it for 16,625 papers, and they did it on the artificial intelligence. So and they did this through November 18th, 2018. And so what did it look like? Well, as you can imagine, Archive only goes back through 1993. They don't have any papers before 1993. So if you look at the 90s, there's hardly even a blip on the bar graph that they have. So for example, in 1993, there were 7. In 1997, there were 19. In 1999, there were 33. But then in 2000, there was a great big jump. There were 125. And it continues to climb. And in 2013, there was a jump to 1,727. But in 2004, it went down to a little over 1,000. And in 2015, again, it was a little bit over 1,000. Then we have a great big jump again in 2016 with almost 2,000 papers. 2017, almost 3,000 papers. And then in 2018, and remember, this was only through November 18th, it went to almost 4,000 papers. So you can see that artificial intelligence is really booming. So there was a shift. They found 3 major trends: a shift toward machine learning during the 1990s and early 2000s, a rise in popularity of neural networks beginning in early 2010, and growth in reinforcement learning in the past few years. So what are some of the things that they saw? So they saw a machine learning paradigm. The biggest shift we found was transition away from knowledge-based systems by the early 2000s. And the computer programs are based on the idea that you can use rules to encode all human knowledge. Among the top 100 words mentioned Those related to knowledge-based systems like logic, constraints, rule, saw the greatest decline. And those with machine learning saw the greatest increase, and those were like data, network, performance. Let's see. So some of the words that they looked at in the frequency of words. So the first 5 words are constraint, theory, rule, logic, and program. And those were greatest in 2000, 2002, 2003, and it's almost gone to nothing here in 2016 to 2018. On the flip side, learning, network, data, task, performance almost saw nothing in 2000, 2002. It started to increase in 2004, and it slowly has been increasing from especially in 2016 through 2018. So you can see we've had a shift in what AI is really doing. So you can see there's a trend of going up and down in different things. So the reason for this change is rather simple. In the 80s, knowledge-based systems amassed a popular following thanks to the excitement surrounding ambitious projects that were attempting to recreate common sense within machines. But as those projects unfolded, researchers hit a major problem. There were simply too many rules that needed to be encoded for the systems to work. So they came to machine learning as a way to solve that. And that's why you're seeing different things. So we're seeing what we call a neural network boom. And I'm not really going to get into a lot of this because it's a little beyond my head to tell you the truth, but just to understand that neural networks has seen a boom which takes over other machine learning methods. And they have a graph in here about how it's going. And they graph neural networks, but Bayesian networks, Markov methods, evolutionary algorithms, and support vector machines. So I'm not even going to get into that. But did you know that AI has been mentioned, artificial intelligence has been mentioned since the 1950s? So this is really not anything new in the area of scientific researchers. So they've been talking about AI since the 1950s. So the rise of reinforcement learning. So what is reinforcement learning? So as well as the different techniques in machine learning that I just talked about, there are 3 different types. There's supervised, unsupervised, and reinforcement learning. Supervised learning, which involves feeding machine labeled data, is the most commonly used and also has the most practical applications by far. However, in the last few years, reinforcement learning, which mimics the process of training animals through punishments and rewards, has seen a rapid uptick in mentions in paper abstracts. So machine learning has gone from, machine learning is all the way up to 50%. Whereas reinforcement learning, which is started in 2018, is really going up in 2018 to 15.3%. So it's gaining momentum for reinforcement learning within machines. So the idea isn't new, but for many decades it didn't really work. The supervised learning people would make fun of the reinforcement learning people, Domingos. This is attributed to Domingos. But just as with deep learning, one pivotal moment suddenly placed it on the map. So that moment came in October of 2015 when DeepMind's AlphaGo, trained with reinforcement learning, defeated the world champion in the ancient game of Go. That effect on the research community was immediate. So what's going to happen in the next decade? We're going to see the same thing that's happened in the 2010s and the 2000s, that we're going to have ups and downs in different things about artificial intelligence. So don't be surprised if you see various things that kind of went out of positive thinking, such as neural networks, which is on its way down now, is going to have an uptick. And we'll probably see machine learning have an uptick and reinforcement learning go down and come back up. So we'll see that all in the next decade. So I'm anxious to see what happens with artificial intelligence. So let's go to the next article, and this was from the New York Times, and it's interesting because it says, how do you govern machines that can learn? Policymakers are trying to figure that out. So in Cambridge, Massachusetts, the Massachusetts Institute of Technology, so I'm continuing it in that same vein, Hal Abelson, a renowned computer scientist, was working with a classroom, coffee cup in hand, pacing back and forth. And the subject was artificial intelligence, but his students weren't your traditional college students. These were policy makers from countries in 36 different nations, and it was called the Organization for Economic Cooperation and Development. And Mr. Abelson was started by giving a brief history on machine learning that started again in the 1950s. Next came a description of how technology works. Then they had some hands-on project using computer vision models, and then case studies. And there were policymakers from countries like France, Japan, Sweden, on a sense of technology strengths and weaknesses and emphasizing the crucial elements of human choice in these. These machines do what they do because they are trained, Mr. Abelson said. The class was a 3-day gathering at MIT, including expert panels, debates, and discussions. They sought to agree on recommendations for artificial intelligence policy by this summer. So that's pretty lofty ideal to have. So by this summer, they want to have agreements on recommendations for artificial intelligence. But where are policymakers supposed to even start? Artificial intelligence seems to be everywhere. It's much hyped, much feared, and little understood. So where do you start with all of this? Some people believe that it's going to be job killers, whereas other people think it's going to be the greatest thing for humanity. It's probably going to be somewhere in between. It's my 2 cents, but I'm not a MIT professor. So the organization declares that when they come, will not carry the force of law, but its recommendations have a track record of setting standards in many countries. So they actually set guidelines back in the 1980s. So they do carry some weight, but it's up to the countries to set different standards on different things. So the recommendations carry weight because the organization mission is to foster economic development, balancing innovation, and social protections. We're hoping to get out in front and help create some sort of policy coherence, said Andrew Wyckoff, the group's director of science, technology, and innovation. So some of the things that they came up with, and I'm going to go over these rather quickly, is rules are needed to make the world safe for AI and let AI flourish. So regulation is coming, and normally that's a good thing because rules of competition and behavior are the foundation of healthy and growing markets. So there was a consensus of the policymakers at MIT, but they also agreed that artificial intelligence raises some fresh policy challenges. Today's machine learning systems are so complex, digesting so much data, that explaining how they make decisions may be impossible. So do you just test for results? In other words, they brought up these conundrums. Do you put self-driving cars through a driver's test? What happens if the self-driving car perceives that it has a problem? Does it drive itself to an auto mechanic, or does it go to the side of the road and call for a tow truck? Those are all things that need to be considered. If AI systems predict breast cancer better than humans on average, do you just go with the machine? Well, probably you do, but again, rules need to be made. It is very clear you have to use it, said Regina Barzilay, an MIT computer scientist and a breast cancer survivor. But what do you hand over to decisions to AI? That's a big thing that we need to understand. If you want people to trust this stuff, government has to play a role. And I agree, government has to play a role, but to what extent? Because you don't want to dampen down all the research and development that's going on. So everyone, not just the superpowers, want to shape AI policy. And that's what these policymakers agree. New regulation is often equated with slower growth, and it can be, But the policymakers at the event said they did not want to stop the AI train. Instead, they said they want their countries fully on board. Nations like France and Canada consider the technology an engine growth and seek to educate and recruit the next generation. Machine learning is the next truly disruptive technology. And this was said by Elisa Strom, who oversees AI strategy in the Canadian Institute for Advanced Research. And I heard that 2 weeks ago at Project Management Institute. They also see AI as a disruptive technology. And project managers have got to understand AI, not to the depths of a scientist, not to the depths of an IT person, but they've got to know how to harness it into their projects. And into project management. International cooperation, the attendees said, would help ensure that policymakers was not left by the default of the AI superpowers, which is like the United States or China. So the United States is a member of the Organization for Economic and Cooperation and Development. China is not. We think there can be a model for the development of artificial intelligence that differs from China or California or the United States, if you want to say it, said Bertrand Biles, the national coordinator for France's AI strategy. China is a government-controlled surveillance state. In the America model, coming from Silicon Valley in California, a handful of internet companies become big winners and society is treated as data gathering resources to be strip mined. And to me, that just sends chills up my spine because I don't want to be a strip mine of knowledge. But we see that nowadays. Look at Facebook, look at Google. The era of fast and breaking everything is coming to a close, said R. David Edelman, an advisor in the Obama administration and the director of the Project on Technology Policy and National Security at MIT. So AI policy is data policy. So one specific policy issue dominated all others, and that was the collection, handling, and use of data. Fast computers and clever algorithms are important, but the recent explosion of digital data from the web, smartphone sensors, genomics, and elsewhere is the oxygen of modern AI. Access to data is going to be the most important thing for advancing science, said Antonio Torralba, director of the MIT Quest for Intelligent Project. So much data is held privately that without rules or privacy and liability, data will not be shared. So we've got to figure out a way to share data and make data the same for all. It can't be just in the hands of a few like we see in the United States. It's got to be in the hands of everybody. So if I want to be able to go out there and harness information on AI and whatever in project management, I should be able to gather as much data as I want to. I shouldn't have to go to a Google or to a Facebook to get that information. I should be able to go to databases that are available to the public. So let's switch gears a little bit now. So let's talk about AI and nanotechnology. How do they work together? So artificial intelligence technology has been developing for many years, says this article. And this article came out of AZO Nano. Not only as an area of technology in and of itself, but also the various spaces and industries where it can be found. So in the first area that they found it was in microscopy. And I read the three paragraphs, and to tell you the truth, it was way beyond me. But this is the microscopy that we don't use in school. It's this absolutely looking at the cell structure and understanding maybe how cancer cells look at each other and letting microscopy define these. So that was what we heard in the last one, that if AI can look at these things, then let's let it happen. So when we use nanotechnology and microscopes, we can see down to the level of cellulars and bringing cells together and binding cells. So that's how it can be used for microscopy, especially in the area of medicine. Another area is in chemical modeling. So we have to be able to look at the nano area to understand chemical modeling. And if we allow the AI and nanotechnology to do the modeling, the chemical modeling, then we can let scientists go and do other things and then just review it after it's done to see if it makes sense. Then the next one is nanocomputing. Unsurprisingly, and this one I did understand a little bit, AI is so extremely useful with respect to the future of nanocomputing, which is computing conducted through nanoscale mechanism. Currently, there are a lot of ways nanocomputing devices can execute a function, and these can cover anything from physical operation to computational methods. So as you can see, we're going to have nanocomputing and nanotechnology coming into the world of AI, and I can't wait to see it. So let's take this a little bit farther. This comes from Singularity Hub, and I found this absolutely amazing to me, and I don't know why we're not doing it in the States, and maybe we are, and I just don't know about it. But it's called How Microbots Will Fix Our Roads and Save Us Billions. This is actually going on in the United Kingdom, and it's being sponsored by the UK government. And the UK, a consortium of scientists led by the University of Sheffield, Professor Kirill Horeshnikov, are planning to use microbots to negate most of these costs, and the cost is $8 billion in the United Kingdom to keep up roads. But they're going to try to negate some of this cost. And the group has received $9.2 million, which is just a drop in the bucket compared to $8 billion with a B, grant to develop and build their bots. So these microbots will come in two versions. One is an inspection bot, and the other one is actually a worker bot. The inspection bot will navigate along underground infrastructure and examine its condition via sonar. Oh, sorry, I hear a downpour outside, so it's raining. The inspectors will be completed by worker bots capable of carrying out repair with cement, adhesives, and cleaning out blockages with a high-powered jet. The inspector bots will be about a centimeter long. Can you believe that? Just a centimeter long. And possibly will be autonomous, while the worker bots will be slightly larger, and they will be steered via remote control at this point. If successful, it is believed the bots could potentially save the UK economy about $6.4 billion. So that will bring $8 billion down to $6.4 billion. That means that they will work on roads will only be about $1.4 billion of their economy. So can you imagine that, bringing it down by that much money? That's amazing to me. It's almost it's almost a little over $6 billion. So the UK government has set aside a $24 million for research into robots for hazardous environments, such as nuclear decommissioning, drones for oil pipelines, and artificial intelligence software to detect the needs for repair of satellites in orbit. Can you imagine setting out a satellite with nanobots, and if it's broken, the nanobots go out and fix it? Could you imagine if on the Hubble telescope, the telescope we have out in space here in the United States, when it first went out, it had the wrong lens on it. If we could have sent nanobots to absolutely fix it, that would have saved millions and millions and millions of dollars. So where else can we see microbots? So they talk about the low-hanging fruit. They talk about it, including it in construction projects. So can you imagine having this in construction projects? Thanks to their size, they can navigate tight spaces, for example, in search and rescue operations, and robot swarm technology would allow them to collaborate to perform many different functions, including construction projects. To date, the number of microbots is relatively limited, but there's firms like Rolls-Royce, which make not the car company side of Rolls-Royce, but the aircraft engines. They actually use 25,000 individual, they use microbots to inspect some up to 25,000 individual parts within an engine. The microbots use the cockroach as a model. And Rolls-Royce believes they could save engineers time when performing the maintenance checks that can take over a month per engine. Can you imagine that? So even smaller successes go further down the scale. Recent years have seen a string of successes for nanobots. Those are even smaller than microbots. For example, a team of researchers from Femto ST Institute have used nanobots to build what is likely the world's smallest house. I don't understand why they did that. Maybe they did it for the microbes. I don't know. But this towering house was 0.015 millimeters, and it was a house and it stands. But what are some other things that the nanobots are doing? They have shown great promise is in medicine. Several studies have shown how the minute bots are capable of delivering drugs directly into dense biological tissue, which can otherwise be highly challenging to target directly. Can you imagine if you have cancer of the liver, putting in the nanobots, taking the medicine directly to the tumor? Such delivery systems have a great potential for improving a treatment of wide range of ailments and illnesses, and as I mentioned, cancer. So we're just going to see an absolute storm of different things that are going to happen in the world of AI and nanotechnology and microbots working with AI. So I can't imagine what the next 10 years are going to bring us. Can you imagine being able to fix our infrastructure here in the United States because it's falling apart and we're using nanobots? We've got bridges that have passed their life, but if you could go in there with microbots and nanobots to do the structural repairs that are needed, can you imagine what that will do? And we can have the money go for building new things instead of having it. And who knows, in the future we may have microbots and nanobots building for us as well. So I hope I've brought you some food for thought on all of this. Project managers are involved in all of these things that I've talked about. So I hope you find it interesting, incredible, and will look into AI because AI is going to come into your project. I don't care what kind of project you use, whether it be AI to help you with your project management information from that aspect, or if it's from the aspect of the actual project itself. But know that AI is coming. Know that nanobots and microbots may be working on your projects as well. So I hope that you have found this as fascinating as I have. I'm Wanda Curley, your authority on project, program, and portfolio management. This podcast has been brought to you by PM Powered, your consulting company on project, program, and portfolio management. Please go to PM Current and follow me on LinkedIn, Facebook, YouTube, and Twitter. I'd love to see you following me and hear what I have to say. Have a great week, and remember, if you have anything to tell me, if you disagree with what I've said, or if you have a project that you'd like to bring out to me, please contact me on wanda@pmpowered.com. I'd love to hear from you. Have a great and blessed week.